Yeah, so can we start?
Sure, yeah.
Okay, yeah. So yeah, first of all, I was really excited to see that you work on deep learning and also neuroscience. So how do these two things work together? I mean,
Well, it's perhaps less how they work together and how they can maybe inspire one another.
yes.
The relationship between the two is. So I guess I can talk about my own experience.
Yeah, sure.
And how it relates, right? So my background is in psychology, and I had been studying psychology, neuroscience, the visual system in particular.
Mm-hmm.
And I kind of became aware of deep learning when Google released those videos a few years ago. Maybe it was just a blog post showing the deep dream.
Okay.
And so with the deep dream images, you could most people know them because they made these, you give an image and it fills it with like kind of hallucinatory dogs and cats and strange shapes, right? And those were kind of cool, but reading through the post, I kind of realized that what they were actually doing and what they're actually showing was that these networks that they had trained learned hierarchical visual features, and that by maximally activating certain parts of the network, you could essentially hallucinate within an image certain things that network had learned to see. And this way of thinking, at least this framework on a high level, is very similar to how we think about the human visual system, where you have early areas of the human visual system like V1 and V2 representing things like points, lines, angles, very simple shapes, and then you build up in the visual system up into areas like V4 and beyond, that we think of as representing actual objects.
Okay.
And so there is this really strong structural similarity between these two things, which is very interesting to me.
Okay. Okay, that's amazing. Okay, so how do you connect it with deep reinforcement learning?
Yeah, so reinforcement learning, the interest there, I suppose, came a little later. But there's a lot of literature as well on the relationship between reinforcement learning and the brain. So there's work that's been done years ago now, kind of showing that, or taking the way in which the brain processes reward signals and modeling it using reinforcement learning.
Okay.
So if you think about something like the dopamine signal in the brain is related to kind of a measure of reward expectation, then or rather, I suppose, it's the dopamine that relates to the error. So if you expect a certain kind of reward, or you aren't expecting any reward, and suddenly you get a big reward, you get that dopamine hit, right?
Yes.
It's kind of how people talk about it. And that can be modeled using temporal difference learning, which is kind of within the field of reinforcement learning.
Okay. So what are you currently working on right now?
So right now I'm working on a number of things. So I'm currently employed at Unity Technologies, which is the maker of a very popular game engine.
Yeah,
it's used in a lot of video games. You've heard of it? Yeah.
Yeah, of course. I've used it.
Cool. And I'm working on coming up with ways to kind of think about how we might do the next generation of AI in games. So instead of having game programmers, or in addition kind of to the traditional setup where game programmers program by hand, these agents or NPCs with all these complex rules, we want to use reinforcement learning or perhaps evolution or some other methods by simply defining the goals of the agents, the goals of the NPCs, and what kind of actions they can take to automatically get intelligent behavior out.
Okay.
And the dream is that game developers, this will make it easier for game developers to create games where interesting things happen.
Okay. So do you think we can probably solve intelligence in this lifetime?
My view on all of this, I think, is that AI, broadly construed, has the ability to is certainly going to impact countless industries, impact the way in which people do work, the way in which people create things, the way in which people communicate with one another. And I think all of that is going to happen before there are sentient AIs. So I think there are bigger things kind of to worry about along the road to that, right? Like thinking about how we structure society when we have the potential for such automation is kind of a bigger worry than what's going to happen if the AIs become conscious.
Yeah, exactly. Yeah, but why do we think that it will go bad? Why can't we think that with all the data we have, it can properly learn to reason the right thing to do, and it will be a good person than a bad person?
Yeah, honestly, I would say that I think some of the people, their fear is that these machine learning systems often retain the biases that were in the data that they were trained on.
Mm-hmm.
And so if we're simply learning to automate our own biases, then those biases are going to be repeated. So things like profiling, right? If you simply train a neural network to profile people, then it's not kind of any more intelligent than the humans were to begin with,
Mm-hmm.
or any more just, right? And I think people have to think very clearly about these kinds of things.
Mm-hmm.
I think, you know, there's kind of this technology is neutral, it's what you do with it. And I think that's somewhat true in these cases where the only problem isn't that AI would inherently be bad or good. It's that we would maybe not think through it enough along the way.
Okay, so how much do you think that this whole fear of AI roots from science fiction, probably Isaac Asimov's novels and all those things?
Yeah, I think unfortunately there's a lot of this. I'm sure you saw like the big kind of news this week, which is that there's this kind of ridiculously
but I don't believe that actually. I don't think
AI,
that.
Right?
Yeah, but I don't believe that. That was I mean, people really hype something that they want to hear. I don't really believe that.
So I think, as far as kind of human nature is concerned, there's an inherent skepticism. Kind of like you say, it's kind of a big part of our culture that like robots are something that's a little mysterious. And so I think people are already somewhat predisposed. And I think it's kind of an extension of, you know, kind of what I mentioned earlier. There are these more immediate ways in which, because of automation, technology is kind of displacing people, and they have this kind of immediate fear. And it could be the case that they're kind of extending that fear further out into the future. And that turns into kind of this existential fear.
Okay. So you studied psychology first. Was there any influence from Geoff Hinton?
Jeffrey Hinton.
Yes, exactly. Yeah, because he also initially studied psychology and then went on to discover this whole Alex Smith thing.
Yeah, there's a connection, I think. You know, one of the people, the founder of DeepMind, I'm quite fond of his work as well. And he received a PhD in neuroscience.
Yeah, exactly.
Mm-hmm. I definitely, you know, there are some people, I suppose, there are different ways of viewing things. There are a number of people who think that there isn't much to be gained from the connection between neuroscience and AI or thinking through it. But I think the truth is that the human brain and mammalian brains in general are really the best example we have of very complex systems that solve problems and do what we want to try teaching AI to do. So if we want to understand, you know, it could be the case that there's multiple routes to the kind of intelligent systems that people are trying to design. But the truth is that the only route that we have any access to right now is the one that nature has created. So we might as well learn the most we can from it.
Yeah. Yes, exactly. Okay, so can we create a proper brain-computer interface using neuroscience and its implications and all those things?
You know, I don't know so much about these things. I wouldn't claim to be an expert at all
Yeah,
in
okay.
brain-computer interfaces.
Mm-hmm.
It's certainly an interesting idea, and there's been a number of interesting, if it's something that's possible, I would say it's in the very early stages.
Okay.
Certainly not something that's coming soon. But there is interesting work that people have begun to do as far as decoding, decoding signals from the brain in quite intelligent ways. So people are able to essentially decode very rough pictures of what people are looking at right now, for example, simply from brain activation patterns, either through EEG or fMRI. So I think that end of it is very interesting. So as far as mind reading, right, is concerned, it's probably going to be the case that as the resolution, the temporal and spatial resolution of the brain imaging techniques get better, and as machine learning methods for decoding patterns get better, we're going to be able to pick up on what's going on in people's heads better. It's the flip side that I have a little bit of trouble with. It's a little perplexing to me, which is it's very unclear that we know any sort of safe, reliable, predictable ways of stimulating brain activity in ways that we want. And that's why I think that the idea of the two-way interface is something that's quite far out.
Okay.
Right now, at least.
Okay. I mean, I talk to people. So one of the most prominent questions they told me to ask is that, do we really need to have a formal degree to work with neuroscience and deep learning, or we can do it through self-study? And if so, what are the proper resources to start with?
So yeah, I'm a big fan of self-study, honestly. So my background being in like cognitive science, psychology, neuroscience, outside of a few graduate courses, I didn't have very much of a formal machine learning background.
Okay.
But I had enough of the statistical background, and there are so many wonderful resources that I think people can do it. I think the big thing is that I would recommend, if they want to get into these fields, there's a certain amount of work that actually has to be put into it. And I guess what I mean by that is I've kind of ran into, it's kind of a trope here, at least in the San Francisco area, that there are people who kind of do Keras tutorials, and they've decided that they're deep learning experts or something like this.
Okay.
And so I think it's very important to understand at as low a level as possible the mathematics, the statistics, the biology, the neurobiology, the neurochemistry on the neuroscience side. But I would say that those resources are available. As far as learning neuroscience, there's a fantastic textbook, Principles of Neuroscience, which anyone can purchase.
Okay.
You don't have to have a degree or something like this. In terms of coursework, on the machine learning side, there are tons of fantastic online courses available. For reinforcement learning, I believe there is a course taught on deep reinforcement learning, and all of the course material is posted online. So certainly all of this is available to people who are learning independently.
Okay. So a few more questions. What is your favorite operating system?
I like OS 10.
Okay.
Well, I suppose the bigger question is, I don't know. I wouldn't personally use Windows, but I suppose you could. The bigger question is, do you have access to a GPU? And if there are the correct OS 10 drivers, I'd use OS 10 on the GPU still.
Okay.
But I think TensorFlow is taking out OS 10 GPU support, so maybe I would use Ubuntu in that case.
Okay. So, what is your big goal?
A big goal? That's a tough one. Well, I suppose my big goal is to learn as much about how thinking and feeling, how intelligent systems work, through modeling them or learning about the human variety.
Okay. Your favorite book?
My favorite book. So fiction, anything?
Yeah, anything. Your favorite book?
It's switching around quite a lot. It's quite
Yeah.
often. I suppose recently I really enjoyed reading The Magus by
Okay.
John Fowles.
Okay. Okay. What drives you?
What's me?
What drives you?
Like a noise?
What drives you? What is the drive force
Oh.
that gets you off the bed every day and working?
Drives
Yeah.
me.
Yes.
I suppose the knowledge that I can see new things, learn new things, and do new things.
Mm-hmm. Okay. And one guy whom you look up to?
I would say right now it's probably, I mentioned it before, the DeepMind founder.
Yeah.
I just want to make sure I think it's Demis.
Yeah.
Demis Hassabis.
Yeah. Yeah. Exactly. Okay.
Yeah, in the past year or so, he's kind of become a bit of my idol. Yeah.
Yeah. Okay. 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 So then the next one might be like not so on point, but still I'll ask it. OpenAI versus DeepMind.
I quite like them both. They both have very, very smart, talented people, brilliant people working for them. I really like the work that John Schulman is doing in reinforcement learning at OpenAI. I really like the very principled theoretical approach that he takes to his work. But on the whole, obviously, as someone who studies neuroscience as much as machine learning, I think my thinking is often aligned more with the work that DeepMind is doing.
Okay. Okay. So last one like this. Would you go to Mars?
No, there's so much of Earth still to see. I'll let other people can go. I'll video chat with them.
Okay. So you like traveling?
Yeah, I do like to travel.
Okay. So if you have to choose one country you want to live for your whole life, which one would it be?
I haven't traveled enough yet. I have to travel more. I suppose this is, of course, the safe answer, but I would probably say that I would stay in the United States just because I know the most about the United States.
Okay.
And it's quite big. So I'd be ensured a lot of variety at the very least.
Okay.
Even if I stayed in one country.
Okay. Yeah, that's it. Okay. Now let's move on to fractals. I saw that you did some work on fractals as well.
Oh, yes, that's true.
Yeah. Okay. So I had this idea, and I would like to talk about it. So, how much do you think that the brain cells comply with the fractal property? I mean, we see one branching out from the other, and we can probably see some influences. So, do you think?
Yeah. So, I think if you look at like the dendrites of cells of neurons, they have fractal properties in them. So I think the idea of fractals, self-repeating patterns at multiple scales, is something that you see in a lot of nature. So I think the brain definitely is itself somewhat fractal. I think in terms of how the brain deals with fractals, which has kind of been more the research that I'd worked on and my advisor had done some with as well, there seems to be some evidence to suggest that the visual system, at least, is more receptive to information that comes in fractal patterns than other kinds of information.
And so, how can we teach a proper neural network to understand the underlying concept of a fractal, that the smallest most property of the smallest most part will be the same property that will be projected on the biggest structure of the same shape? Can it be one-shot learning or transfer learning?
So this is maybe a disappointing answer, but I think I'm not sure yet. I think it's one of the, if you look at the way just a simple convolutional neural network is structured, it's not really designed to, as it moves up the scales, it essentially averages out or kind of forgets lower level information.
Okay.
So I think we kind of need to come up with perhaps new architectures for neural networks that are able to take into account information at multiple scales all at once.
Mm-hmm. What is your PhD thesis? What are you working on?
So I'm working on right now the relationship between reinforcement learning and the way in which the human hippocampus is used to model, or I guess the human hippocampus can be thought of as representing things related to the spatial position of an animal, for example, as it moves through space.
Mm-hmm.
So it's used, it plays an important role in navigation, for example.
Mm-hmm.
When humans or animals have some goal in space that we need to navigate to.
Mm-hmm. Okay.
And it turns out that there are a lot of connections between reinforcement learning and this specific structure that I'm quite interested in, and so I'm writing on that right now.
Okay. So what particular applications can you find, like building robots and things?
In terms of practical applications of that, it's certainly possible. You know, my hope is that by first kind of enriching how we think about the human hippocampus, we can
Mm-hmm.
then take what we've learned from that to build new deep learning models that are able to do things like planning and prediction and goal-oriented navigation
Okay.
better than the current models.
Okay.
So the hope is that there's this kind of like virtuous cycle.
Okay. Okay. There's one more question I just remembered. I just recognized. So there are studies that say that the model of brain is in such a way that it does not store data, but it rewires itself to remember the kind of activity it did before when it encountered a particular activity. So how much do you think this is correct, and can we make a computer that is based on a particular architecture such as this?
So I would say on the long run, it's definitely true that the brain doesn't store information.
Mm-hmm.
What the brain does is it is essentially like a pattern prediction, giant, very complex pattern prediction system.
Mm-hmm.
And I mean, similarly, you know, the truth is, I think that on a very basic level, artificial neural networks
Mm-hmm.
are doing something similar to what the human brain does. The problem is that they're a ridiculously simple version. So of course they aren't capable of very interesting behavior.
Okay.
But I think this fundamental idea that you have weights and activations, and the meaning of things is stored within layers, not as some sort of separate thing that gets read out, but as kind of an active process,
Mm-hmm.
is the right way to think about things.
Okay. Okay. And how do you think quantum computing will help machine learning and deep learning and robotics?
I have no opinion on that, unfortunately.
Okay.
I think it's still very early. So there's some interesting kind of theoretical work, but there's so much more to do without quantum computing.
Yeah.
Have a good
Yes.
night, I guess.
Yeah, sure. Thank you.